Hi there, this is Mar Haddad here again. In this lecture I have to do a lab, and in this lab I have to speak about the Ospf hello package. So I'm going to play a little bit with the things that they said they should match. So like the area ID, like the authentication, like the dead interval and the hello interval. So I'm gonna play with that to check if we change it, then if the neighborship will stay or not. As you can see here, we have a lab of 11 points. Before I start doing those points, let's go to the lab scenario to show you what we need to do. Then I will come back to the points and start doing that. So this is my lab scenario. It's very simple. I have two routers, router 1, router 2 connected to each other. And I just want to enable Ospf on those two routers and advertise the connected network. We do have only one network. We advertise it, and then we should have neighborship point. Then what I'm going to do, I'm going to go to router 1 or router 2, we'll see in a moment, and I'm going to change, for example, the hello interval, the dead interval, to see if the neighborship will stay the same. So I make, for example, hello interval something else on router 1 than it is on router 2. Then we'll see if the neighborship will stay or not. Because remember when I was speaking about the last lecture, about those things should match, hello dead interval, the area ID, the authentication, the stub area flag, I'm not going to do it because that's not part of the CCNA. Alright, so I'm going to play with that to show you that once you change it, then the neighborship will be gone. So this is what we're going to do in this lab. Let's go back to the points now and start doing them. Port number 1, all IP addresses are already configured as on the picture. Let me just put the picture. And I have already put the IP address on Ethernet 0/0 for router 1 and router 2. Then port number 2, ping from router 1 to the interface. Here should be Ethernet 0/0 and not Ethernet 1 of router 2. Do you have a reply? Let's try. Let's go to router 1 and from here ping to 192.168.12.2, and we do have a reply. Port number 1 and 2 are done. Now I need to configure Ospf. So configure Ospf on router 1, advertise the connected network, and also I will do port number 4 together to configure Ospf on router 2 and advertise the connected network. Alright, let's do that. So I will go to router 1 first, configure terminal, router Ospf1. Let's put the router ID to be 1.1.1.1, and then network 192.168.12.0, 0.0.0.255 on the area 0. So that is done on router 1. We go to router 2, configure terminal, router Ospf1, router ID, we'll make it 2.2.2.2, and then network 192.168.12.0 and wildcard mask 0.0.0.255 area 0. And in a moment we should have the neighborship formed. Port number 3 and port number 4 are done. Check if both routers form the neighborship in Ospf. Let's have a look. Let's go to router 1 and the command is show IP Ospf neighbor, which we already know. And here we go, it has made a neighbor with the router 2, which has the router ID 2.2.2.2, so that's full. On router 2, show IP Ospf neighbor, and also form neighbor with 1.1.1.1, and it is full. Very good, so far so good. This is a review of what we have done in the previous lab. Point number 5 is done. Point number 6, change the hello interval on router 2 to 12 seconds. Do the router have neighborship still? So let's go to router 2. Let's first find out what is the default interval for the hello and the dead interval. To do that, I have to write show IP Ospf interface Ethernet 0/0. So over here we should find out what is the hello interval and the dead interval. Let's have a look. You can see here by default the hello is 10 seconds and the dead interval is 40 seconds. That means it will send hello every 10 seconds. In case it doesn't hear from the other router, it will wait until 40 seconds. And then if there is nothing received, then it will make the neighbor down. Alright, so this is the as you can see here, that is the one for router 2. Let's do also for router 1, show IP Ospf, and then we have to go to the interface Ethernet 0/0, and also it's the same, hello is 10 and dead interval is 40. Now they said to change the hello interval on router 2 to be 12. Alright, so it's not the same as with router 1. So we have to go to the configure terminal interface Ethernet 0/0, and then IP OSPF, and here you have to say hello interval ? You have from 1 second to 535 seconds. Let's change it to 12. ? And that's it. So let's wait a little bit now, and we should in a moment see that the neighborship will go down between router 1 and router 2. Why? Because router 2, if we go here to, again, show IP OSPF interface and Ethernet 0/0, we see that the hello interval has been changed to 12, and also the dead interval has been changed to 48, because it will always take 4 times more than the hello interval. Alright, so let's check now if the neighborship is still formed. I'm on router 1 now, and you can see directly now we have something here showing up that it has waited, and then it is going the neighbor, which is 2.2.2.2, from full to down. Neighbor is down. So if I say now show IP OSPF neighbor, we should see we don't have the neighbor anymore. Alright, point number 6 is done. Point number 7, change the hello interval on router 2 to 10 seconds again. Is the neighborship formed again? Let's do that. Let's go again to router 2. Let's clear everything, and we go again to the interface Ethernet 0/0 IP OSPF hello interval. Let's put it 10 again. And now we say do show IP. You can see that it's already formed, but if you want, we can just justify that. Show IP OSPF interface Ethernet 0/0. We can see that now the hello is 10 and the dead interval is 40 again, same as on router 1. That's why if now we can see, and we say on router 1 show hello OSPF neighbor, then we do have the neighborship again. Alright, so you can see that's the hello interval and dead interval, they should be the same on both routers for the neighborship on OSPF to happen. Point number 7 is done. Point number 8, put router 2 in an area 1. Did the two routers lose their neighborship? So what I'm going to do now, I have to think that this is router 1, which is on router 0, and I put router 2 on another area, on area 1. Alright, because remember here, if we look again, that the area ID should be the same. So if there is one router on area 0 and one on area 1, then the neighborship will not be formed. So let's do that. Let's go to router 2, and we want to put it now on area 0. So I will go again to the router OSPF process, which is 1, and I will recall the command that I have used. Let's see if we can get it. This one. No network. So I'm taking this network from area 0, and I will put it now on area 1. Let's have a look, and here I'll have to say area 1, enter. So now we have this network is on area 1, the other network is on area 0, and we have to wait to see if there is any neighborship that is gonna be formed. And I'm telling you from now, it's not gonna happen. Alright, because if we say now show IP protocols, if we say show IP protocols, and we look here, we can see that this network now is on area 1. And look, it's saying received invalid packet, mismatch area ID from backbone area, from 192.168.12.1. And as you can see here, it's saying that there is a mismatch between the areas, because here is on area 1, the other side, which is router 1, is on area 0. Show IP protocols. You can see that this is on area 0. So one on area 1 and one on area 0, the neighborship is never gonna form. Show IP OSPF neighbor, you see there is no neighborship. Point number 8 is done. Point number 9, put router 2 in area 0 again and check whether router 1 and router 2 form the neighborship again. So let's do that. Let's go to router 2 now, which is still getting this error. And let's change that. Let's go to the router OSPF 1. And then we change this one, and let's put here no. I don't want this to be on area 1, but instead I want it to be on area 0. Alright, so in a moment we should see that here we go, the neighborship has been formed. You can see that it's loading to full, and now if I say do show IP OSPF neighbor, we see that router 2 has formed the neighborship with router 1, it is full. And we will see also that router 1 show IP OSPF neighbor, he formed the neighborship with router 2. So also the area ID should be the same on both routers for the neighborship to be formed. Point number 9 is done. Point number 10, change the authentication on router 2 from none to plain text and put a password of 123456. So what does it mean here? If you go back to the picture, what I want to say here that on OSPF you can make for the neighbors some type of authentication. So you can use whether the plain text or the MD5 dashes. Alright, so using the hashing. Now, why we need to do that? Let's imagine that instead of having this connected directly to each other, so let's forget about this link. Let's think that we have a switch here, and on this switch this router is connected to it, and this router is connected to it. And maybe there is one intruder, a hacker, he put a router or he put a computer which is emulating OSPF. Okay, and he make neighborship because this is a multi-access network, so a broadcast network. So he can form neighborship with router 1 and with router 2. All right. Then in this case, if he form the neighborship, then all the routes he will be receiving them. And that's something we really don't want because he's a hacker. He can profit from that to do some type of attacks. So what we can do instead, we can do some type of authentication using some password. So for the neighborship to be formed, then they should have the same password. And here we have two ways to do, whether with a plain text, with just a password plain text, or using the MD5 dashes. All right, I'm going to show you now both ways. All right, so what I'm going now to do, I'm going to put a password on router 2 because router 1 and router 2, they don't have any password now. It's none. So I have to put on router 2 a password, not on router 1, and you will see the neighborship will not be formed because, again, if we look here, you see the authentication, it has a star, so this should match as well. So how to do that? Let's go to router 2 now. And on router 2, we have to go to the interface Ethernet 0/0, and here I have to say IP OSPF authentication, and that's what I need to do. So that means I'm enabling the authentication on the OSPF. I'm using now the plain text IP OSPF authentication, and then I will say IP OSPF authentication key, and I mention what is the key. You can see it's saying a line. All right, so you just put the key that you want. So they said put 1 2 3 4 5 6 to make it very simple. All right, so don't use this password, but just to show you that that is a simple one. All right, so that's what you need to do. And as you can see directly, this neighborship has gone down. Why? Because router 2 has a key, router 1 doesn't have a key, then this has gone down. So if you want, we can go to router 1 and we go to the interface Ethernet 0/0, and I'll say IP OSPF authentication to enable this authentication, and then IP OSPF authentication key, and we put 1 2 3 4 5 6. So this is plain text. So the key 1 2 3 4 5 6, which is sent between the two routers, is sent clear text, so anyone can check it. And you can see once I put here the key, then the neighborship has been formed. To justify, show IP OSPF neighbor, and you will see that we do have neighborship. All right, so that is one way to do it. The other way to do it is to use the MD5 dashes, and I'm going to show you that in a moment. So to do that, let's first take out the authentication key that I have created. So I will go to the configure. Let's clear everything, go up. All right, configure terminal, interface Ethernet 0/0, no IP OSPF authentication, and should do the work. And I don't think we need to also take out the authentication key. Yeah, okay, let's do that also. Alright, so this is done over here. Over here also no IP or Ospf authentication, no IP or Ospf authentication key. Alright, so now we don't have any key on both routers. Now what I can do is that instead of the keys to be sent as plain text, I can use some type of hashing, so they will be sent somehow like encrypted, so no one can see what are the keys that we are using. So to do that, I have to write here on the interface again IP Ospf authentication, then question mark, and you can see here we have the message digest. Alright, IP Ospf authentication message digest, so that's what I have to write. So that means I'm using the message digest over here, and then I have to say IP Ospf message digest key and then question mark. So you take a key number, which is anything 1, and over here you have to say MD5, and you put the key, which is 1 2 3 4 5 6. All right, so now Ospf has been here on this side on the interface. It has an authentication key using the message digest MD5, which is 1 2 3 4 5 6. So this key, when it's sent from router 1 to router 2, then it is encrypted and no one can intercept it. But you see that there is no neighborship anymore, because here it has this key and the other side it doesn't have a key. So we go to router 2 now, and on this interface I have to say IP Ospf authentication and then question mark and then message digest, then IP Ospf message digest and then question mark, we say the key which is 1, MD5, and then the key which is 1 2 3 4 5 6. And now by doing that we should have the neighborship up and running. Here we go. So you see that it has now it went from loading to full, so that means there is neighborship. To justify this, we go to show IP Ospf neighbor. It is now there, and then we go to router 2 and we say show IP Ospf neighbor, and also we do have neighborship. So this is the two ways to use the authentication, whether the plain text or you use the MD5. Point number 10 and 11 are done, and with those two last points I have showed you how you can play with the hello package, and also to show you that it's very important that the hello interval, the dead interval, the area ID, and the authentication, as well the stop flag, which is something we don't have to speak about it now because it's not part of the CCNA, but those are very important to match between the two Ospf routers for the neighbors to happen. So this is what I wanted to show you in this lecture. I hope it was informative for you, and I'll see you in the upcoming lecture.